Alright, geometry, we are going to look at section 5.3, one-step congruence proofs. Just a refresher as far as what we looked at already in chapter 5. Section 1, we looked at the CPCF and how all the parts of corresponding figures match up and are congruent. And then in section 5.2, we looked at the difference between congruence and equality. Equality always referring to quantities, congruence referring to figures. So 5.3, we're going to look at one-step congruence proofs. So the big thing will be referencing congruence in these proofs. Alright, if you were looking at your book on page 256, there's this table, and what it has is, well, let's see, 12 of the most commonly used congruency theorems, postulates, things of that nature that you're going to use. So I would definitely take a little bit of time to look these over, maybe draw a picture of them if you don't remember. They also tell you the lesson they came from, so you could look back in your notes and reference them since we already have pictures. But we're going to use a lot of these as our justifications. So again, just look over them, read them through. You can pause the video, take some time to look at them because we're going to use them a lot, so it's just a good refresher. The book puts these 12 here because they know that we're going to be using them. Okay? So take some time, look those over, make sure you remember them all. Alright, so now that you've taken some time to do that, we are going to look at example 1. In your book. Alright, so example 1 says, given that V is the midpoint of AP, what can you deduce? So I'm just going to draw this. Midpoint, so I'm going to put these congruency marks in there. So what can you deduce? Well, by me putting those tick marks in there, I already deduced something, and that was that AV equals VP, which we know is essentially the same inequality as this statement in congruency. Okay, so that's something we can deduce. Let's see what the book has to say. It's often helpful to draw a figure, okay, which we did. From the definition of the midpoint, you can conclude that segment AV is congruent to segment VP, which is exactly what we have. You can write this because the definition of the midpoint, the more information that's given, the more that you can usually deduce. Okay, so what we're trying to practice here is if we have this much, what can we get to? So think about what, if this was the antecedent, what would be the consequent? Here would be our consequent of that. Okay, so let's look at example 2. Given segment PR and segment SQ are diameters of circle O, make and justify a conclusion. Okay, so I'm going to draw a picture again. So I have circle O, P, R, and SQ are diameters of the circle. What can you conclude about this, and how can you conclude those things? Well, we could start with something simple like SQ is congruent to PR, and we know that's because they're both diameters, and so diameters would be congruent. A little bit more, we know these are all radii, so I think we could get something there. So SO is congruent to OQ, and PO is congruent to OR. And how is that? It says we need to justify this. This is all coming from definition of a circle. If you remember looking back at the definition of a circle, it talks about that we have radii that are congruent, and hopefully you saw that on the table that you looked at the beginning of today's lesson. Let's see what the book has to say. Here we go. And they actually wrote them all congruent instead of writing them as two, which is fine. I didn't think about the angles. There are some angles that we can look at. PR and QS are intersecting, so they form vertical angles. Very good point. So here's another possible conclusion. So back here, we could talk about this angle and this angle being congruent because they're vertical angles. So we would have angle ROQ is congruent to angle SOP by vertical angles theorem. Okay, so we've deduced some things and we gave a justification for why we could deduce those things. All right, let's do some more practice. All right, let's look at example 3 on the next page. Given that we have a reflection of triangle ABC and it's going to be ADE. Okay, so let's draw a picture. I was checking to see if they had drawn a picture for us, but so let's try to imagine this. So we have a triangle ABC, and that has to become ADE. So something like this. What can you deduce? Okay, so think about that. What could you figure out from this? We know it's a reflection, so think about ABCD theorem and all the things that stay the same. We know that since it's a reflection, we know that those two triangles are going to be congruent. So there's so many things. So let's see what the book has to say about everything that could be a possibility. You can deduce that the triangles are congruent, so we already said that. And we might want to write, okay, the definition of congruence gives us the fact that ABC is congruent to ADE. And that's because of definition of congruence. And then the book goes on to say, if you'd wish to be clearer, you could write this huge sentence, which I'm not going to ever ask you to write all of that out. If you can give me a reason for why you can deduce something, I'm good with that. Then it goes on to say how you can get a little more specific about the corresponding parts. So we could just talk about, for instance, angle B and angle D. We could talk about segment BC and segment DE. So we'll just do that one. We know that BC is congruent to DE. How do I know that? Well, we've already shown that the triangles are congruent. Okay, and in section 1 we said if we know the figures are congruent, then we know the corresponding parts are congruent, which these are corresponding parts of congruent figures. So if you remember that abbreviation, corresponding parts of congruent figures. Okay, so that would be my justification there. Alright, let's look at example 4. Given that M is parallel to N, justify the conclusion that angle 1 is congruent to angle 5. Okay, so this is a picture that they have provided, otherwise I don't think it would make a whole lot of sense. So we are taking that M is parallel to N, and they have that marked on here. How do I know that 1 is congruent to 5? How do I know that 1 is congruent to 5? Think back in your brains. What tells me that 1 and 5 are congruent? What was that justification? Hopefully, you remembered that 1 and 5 are corresponding angles. This suggests that the corresponding angles postulate may be appropriate. And remember that postulate's a biconditional, so it goes two ways. So we just have to remember we have to write the way that the problem is written. So in this case, the antecedent, the thing that comes first, said that lines are parallel. And the fact that they're parallel is giving us that corresponding angles are congruent. Okay? And that's what they have here. And remember, we use this kind of abbreviation so we didn't have to write that huge thing out. Okay, so what is this justification for example 4? And what they were trying to really hit home here was to make sure you have the correct order of biconditionals. So whatever in the given has to be your antecedent. And we said here we have parallel lines, which then allows us to say that corresponding angles are congruent. Alright. Hopefully these examples are kind of refreshing our memory on some of the justifications that we have. Alright, let's look at example 5 up here on the next page. Alright, in the figure at the left, GHI, angle GHI, which is here, is the reflection image of JHI over line HI. Okay, justify the conclusion that angle GHI would be congruent to angle JHI. Okay, so think about it, and right now I'm sure you're thinking, well, like reflection. It's a reflection, so it's an isometry, which makes congruent figures. Exactly. We've talked about this a lot, so let's see how the book presents this for us. Just like I said, examine a list of possible justifications for angles to be congruent. Only one involves reflections, which is the definition of congruence, which we just talked about. To be clear, you may write the appropriate direction of the definition. So if one angle is the image of another under an isometry, then the angles are congruent. If you want to write all that, that's totally your call. But we know that's because of the definition of congruence. So for example 5, y, and we said it's definition of congruence. And in this section, we're going to use this as a justification a lot because we're talking about congruency proofs. So we're going to use that quite a bit. All right, the last example. I like this because now it actually uses the language of proof. We still have given, and then we are going to prove something. So when we're saying to prove something, we're just, needing to justify it with something, okay? So given, so this is my antecedent. This is what I know. It's there. I just have to accept it. So the reflection of angle GHI equals angle JHI. And to prove this, so you'll notice this is the same thing that was in example 5, and we're just going to practice making it look like a proof. Just different wording. The answer is the same. So I'm just going to give you a little preview of what proofs look like. We usually have 2 columns when we are doing proofs. Here are all the reasons on the left side, and then all the justifications. And step 0 in this book is usually the given. So I'm going ahead and copy that. So this given right here. So the reflection of angle GHI equals angle JHI. So that was my given statement. And what's the reason? How do I know this? Well, it's given. Okay, so everybody should get 0 step correct, I think. Okay, and this one's going to be only one step because we only needed one step for it. And what was I trying to prove? Angle GHI is congruent to angle JHI, and what was the reason for that? The reason was, well, the definition of congruence tells me that. Okay, so that's what your proofs are going to start looking like. These are just one-step proofs, and like I said, we'll get some that are 4 and 5, maybe 6, but that's what proofs look like. All right. If you're not remembering some of these reasons, remember you can either flip back in your notes or in the back of the book. They have all the theorems and postulates listed in order of chapter, so you could look there and that's a quick reference for you. All right? Have a good day. I will see you soon.